Hey guys, this is Academic Physics. We are in Unit 3, Section 4. We're talking about torque, Part 2. And to talk more about torque, we need to actually cover center of gravity. So the center of gravity has to do with how objects stay balanced. So when the center of gravity is supported, an object is going to stay balanced. So the center of gravity is just the point. So what is it? The point at which all the mass is basically averaged, or the average location for all the weight of an object. So if you have a lot more mass on one side, then the center of gravity is going to be closer to that side because it's on average, where is the mass? When an object spins in space, it's going to automatically rotate around its center of gravity, and you've experienced that if you've ever played the water flipping bottle game. And it's also sometimes referred to as the center of mass because mass is what creates weight, which we deal with gravity. So gravity is pulling of the mass to create weight. So where is the center of gravity for an object? So in a symmetrical object, it's just the center of all the axes. So as in, if the weight is equally distributed throughout an object and the object looks symmetrical, so if you cut it in half, it's the same on both sides, then if you just draw straight lines halfway through, that's where the center of mass is going to be, or the center of gravity. Now keep in mind there may not be matter there. So like in the donut or in the cup, the center of mass, their center of gravity is right there in the center, and there's nothing there. And that's okay. We can say that the weight averages to be at that point, even if there isn't any weight there. So how do things stay standing? For an object to remain upright, its center of gravity must be above the area of support. So if we look at this picture, this is a symmetrical object, so the center of gravity is right in the center. And if you draw a straight line down and there's support there, then it's going to stay standing. This one, the center of gravity is here, and when you draw straight down, there is no support for that object, so it's going to topple over until it gets to the point of support. So it's going to fall until it hits something that supports it. So an object will topple over if its center of gravity is not above the area of support. So how do you identify the center of gravity for an asymmetrical object? And the best way is just to hang it from a string. So when hanging from different points, the center of gravity is always going to fall directly below the point of suspension. So if you notice, this is a very oddly shaped object, and even though it has this giant area over here, it's still right down the center, and it could have turned on its own if that wasn't the center of gravity. So you can treat the center of gravity like all the weight comes from this point, thus causing a weight vector straight down. So if you're asked to label the center of gravity, the weight of the center of gravity, you're going to find the center of gravity and then just draw that force vector. Remember, a vector is going to be shown as an arrow in the direction that it's facing. So even though this whole thing has weight, you can think of all the weight coming from the center of gravity, and there's that downward facing arrow, which is why if the object is not supported under the center of gravity, you've got a force pulling it down, and there's no normal force to cancel it out, so that is how things fall over. Okay, good luck with center of gravity, and I will see you in the next set of notes.